the F-sharp user group. Very excited today to have the first presentation ever on Deedle, which is really cool. There is one F-sharp event coming up, which is the F-sharp in Finance event, I believe next month, early next month. But you know, it's pretty much finance oriented, lots of different speakers. Don Simon's going to be there. You should check it out if you work in the city. Your company would probably pay for it. And so, other than that, I'd like to just hand it over to Tomas and Howard here, because I'm just super excited to find out about how Deedle works.
So I'm going to start giving you kind of a bit of an overview of what kind of this space that we're working in, and what Deedle is for in the context of that. First, the obligatory slide on the F-sharp software foundation, which you've probably seen 20 times before. So F-sharp software foundation is a group of people who are dedicated to providing a good open source, generally cross-platform environment using F-sharp and collecting together a bunch of information about libraries and user groups and how to teach F-sharp, etc., etc. So that's that. And more relevant today is the working at the foundation has a number of working groups. One of them is the data science working group. So there's a bunch of others. There's one for finance and there's one for I can't remember because I'm not involved in any of the others, but data science working group I am involved in. So at BlueMountain, this is quite important to us because we do a lot of stuff in this space. We have a lot of what we do is gathering data and analyzing it and visualizing it, producing reports and things like that. So this is kind of relevant for what we do. And Tomas is also quite significantly involved in it, along with Matthias, who I think has presented here a few months ago on did the tutorial on machine learning. So what we're kind of working towards in this is an environment we're currently calling FS Lab, which the idea is kind of an open source environment for doing basically everything, a batteries included distribution of everything you need to do data science in F-sharp. And the idea is there'll be like a single NuGet package you can just reference, and it will give you all the packages you need. And we have a website which I think at the moment doesn't have a lot on it. Well, I can't even go to it. There we go. So that's how far we've got so far. So this is an embryonic project, but we're hoping with the help of the community, the F-sharp community, and we want everyone to get involved in this if they're in this space. Hopefully we can produce a lot of stuff that builds overall a nice environment. So I have kind of two announcements as part of this this talk. The first one is we are kind of relaunching the R provider. So this is my first project at BlueMountain when I joined about a year and a half ago. I was building the R provider, which is a type provider for F-sharp, so you can talk to the statistical package R. I built it for the needs of BlueMountain, and we use it quite heavily. But up until recently, it wasn't particularly consumable by others. The documentation was pretty poor. There wasn't a lot of kind of tutorials and things. Recently, other people got involved. In fact, I recently had the pleasure of reviewing a code change by Jon Skeet, who, in case you don't know, wrote F-sharp. I was able to comment on his code and say, you got this bit wrong. You should have used this function instead. It's pretty amusing, at least for me. So I just want to show you if I can actually get the mouse to move.
My notebook is completely. There's nothing wrong with my computer.
It's just my fingers. I keep telling Tomas to get a new computer. So I'll make this a bit bigger. So you can see we've got a nice call this browser. A nice front page. We've got a bunch of documentation here, and I'm going to show you this little video because it's only 2 minutes long, and it will do a better job of explaining the type of library than I did. Whether the sound's going to work is another question.
Did you plug it in?
No, that's not quite good.
Well done.
We'll start it again once I figure it down.
I guess the sound is not switched on, so.
Instead of RStudio,
Oh,
is
there we
that
go.
F-sharp
So
has
we're gonna start
fantastic
again.
data manipulation.
All right.
Is that Matthias?
That is Matthias. So he's one of the people who've been making this whole thing better. So here we go.
The F-sharp archetype provider allows you to interoperate with R from F-sharp. Once the NuGet package is installed, you can discover available R packages with IntelliSense and use R to perform statistical analysis or visualize your .NET data on the fly. The main benefit of using the type provider instead of RStudio is that F-sharp has fantastic data manipulation capabilities. For instance, you can use the WorldBank type provider to access live data from the WorldBank with minimum effort. All the country indicators from the WorldBank are discoverable with IntelliSense. Without having to download any data file, you can just retrieve the GDP of China from 2000 to 2010 and use R to create a bar plot. You can also use a friendly link query syntax to filter data. In this case, extracting countries which had a population larger than 100 million in 2000. Once that sample of countries is constructed, you can navigate and search all the available country indicators from the WorldBank. You can review the definitions as you access them and begin data exploration. Here, we are going to retrieve a few indicators: the country growth per capita, the percentage women in the workforce as a measure of gender inequality, the proportion of the population under 14 years old, and the CO2 emissions relative to GDP as a proxy for pollution. We can now extract the data from the WorldBank over the wire and convert it into a R data frame. Once this is done, we can plot the variables against each other to identify patterns in the data. In our example, we can see that the three variables seem to be related. Better gender equality and higher pollution level appear to be related to higher country growth. Hope you enjoyed this demo. Thanks for watching.
I'm going to do all my talks if I just record it. Having other people record it. So, you saw here, you can, a lot of this was about the WorldBank type provider, but you can, with the R type provider, you can call, basically the idea is you can call any function that is implemented in an R package, an R library, and you can just call it as if it was an F-sharp function. You get IntelliSense, documentation, and all that stuff. And it can pop up windows for graphics, etc. I think Tomas is going to be doing a bit of that later. So please, if you do anything in the statistical or visualization space, it's a good package to look at because R has a pretty great set of libraries. But the language itself is, I guess, it's fine, but it's for what you're trying to do. But it's not like a very strong language for building systems. So that's why we like to combine F-sharp for data acquisition and data processing, and then use R for certain specific packages. And what the sort of stuff that Matthias is doing there, that's the typical kind of data science workflow where you're pulling in data from lots of places, combining it together. And he was using some sort of expressions and things like that, which works okay. But a much richer way of doing it is what we're going for Deedle. Now Deedle is stands for .NET Exploratory Data Library with a few E's for excellence and more exploratory, because the idea is that it's interactive. You can combine together data, align it, and do all sorts of things like that. So if you've heard of pandas in the Python space, this is really the top-notch implementation of this kind of library. And we've modeled some of the quite a few of the concepts around pandas. And again, this is the main thing that Tomas has done during his internship. And the documentation here is really outstanding. We have got a bunch of tutorials. We've got documentation on using it from F-sharp, documentation on using it from C-sharp, and you can go through this. And there's lots and lots of examples, lots of information. extremely well put together documentation. So again, it should be easy to use, even though it's an open source project. It should be really easy to use. So what is it for? So I mentioned exploratory data analysis. Exploratory, that kind of has a specific meaning in the statistical context, but what we really mean is, it makes it easy to pull data together in ways that you don't have to think about upfront. You just kind of look at the data and then say, okay, now I want to do this, now I want to do this, and you haven't got a big amount of overhead. Time series analysis is what we typically do in the finance space. We're looking at some price or measure over time, and we have some rich functionality for that. Data processing, transformation of various kinds, and data cleaning, which you probably want to do when you're doing machine learning. You typically got to get data in from different places, clean it, normalize the data, encode data in numeric ways so you can use a standard machine learning package. But Deedle itself does not have anything in the space of kind of machine learning. It has very basic statistical functionality and no visualization, but we've made some attempts so far to integrate Deedle with other packages that do stats and visualization, including the R pipe. This is actually our third attempt at BlueMountain to build a series and data frame library. So we hope we've actually got it right this time. The reason we did the third one, the first one was actually done for Python, which was what we were originally trying to use for our interactive environment. When we aborted that and started using F#, we built another library because the original one was very dynamic typed, and we wanted to kind of exploit static typing a bit more. We learned a lot by doing that, and particularly having a combination of programmers using it, and we have like portfolio managers, researchers, quants basically using the library, and they're coming at it from different perspectives and giving us a lot of feedback. So we ended up doing, we made a few mistakes in that design, and we ended up wanting to kind of do it again to fix the mistakes. At the same time, we happened to have a guy named Adam Klein join, who he'd worked on pandas with Wes. So he knew a lot about kind of building this kind of library. They're both at AQR, another hedge fund, together when they were building pandas. He also built a library in Scala called Saddle, which is basically a Scala version of Deedle in a way, but Deedle is actually ends up being much richer. And then we had Tomas starting his internship, so we figured this was a good time to kind of address our need to do the third iteration. And as I mentioned, it's well documented, it's open source, and most importantly, it is ready for you to contribute. So really want to get people involved in this. So a couple of things on the concept, and then Tomas can do some demos. So we've got two main concepts. One is a series, not necessarily a time series, but it often is. So this is basically a mapping from keys to values. Series are immutable, and the key, as I said, is often a date or a time, but it can be anything you like. It can be an object, or it can be any kind of F# data type. It also has, importantly, rich support for missing values, which is in a real world data. This is extremely important. So it has rich support for missing values, and it has good facilities for kind of working with these series in safe ways that don't do things like completely ignore missing values or give you some default like 0 or something like that. It has a proper first-class support for it. And we tried to make it kind of friendly and consistent with other similar things you might use in the .NET world. So, and if you use it from C#, it has kind of link-friendly syntax, so you can do slacks and wheres and things like that. And although we've probably not tried it, it should work with we designed it to work with the link query syntax, the problem, all of that. In F#, it has a module-oriented interface that is like seek or list or array. So we tried to make it kind of consistent to work with this. The frame is you can think of as being a bunch of series, which are columns. And this is really, you can also think of it as being a mapping from a row key to a column key, which gets you to a value. So it's kind of like it's a two-dimensional thing. The column keys are frequently strings, right? So if you think about relational databases or most kind of tabular data, often your headings are strings. But in Deedle, they don't have to be. They can be any type you like. The same as the row keys. You can transpose them and work with them in both ways. So a frame is type safe on its row and column keys, and that's reflective of the type of the frame. But the value types are heterogeneous, which is, although it's a little unfortunate in F#, practically speaking, you can't really do any better than that. So you sometimes have to kind of pull things out and assert their types. In practice, it works pretty well. And again, another practical thing that we ended up with after experimenting on is it's column-wise mutable. So you can't add rows to it, but you can add columns to it, and that mutates your instance. It just became too difficult to work with if it was completely immutable. And I think the richest functionality, or the most important functionality when working with kind of time series data is alignment. So you can put in two series that have different timelines, and it will align them appropriately, and then you can end up with you'll frequently end up with missing values in the frame, and it will allow you to fill those in some ways, or allow you to kind of, when you join the series together, it allows you to figure out an appropriate value for other columns in various ways. And also it supports hierarchical indexing. So you don't just have to have a single name for your column, if it's a string, but you can have a hierarchy. If you think about, you have well, actually Tomas is going to demonstrate this, so I'm not going to go into more detail about it. But that's very useful for kind of multi-dimensional, modeling multi-dimensional data. All right. Now the boring stuff is over, and Tomas is going to
More boring stuff is
show you
coming.
more boring stuff.
Well, now the non-work. I'll have to disconnect the sound. So I'll basically try to go through 3 different samples, depending on the time. We'll see how far we get. The first one is looking at the Titanic data set. So let me switch to Visual Studio. And the question is this the Visual Studio version I want? Yes, that's looking good. I'll actually start by proving that the Deedle library is available on NuGet. So I'll start one fresh instance of Visual Studio. It works with both whatever .NET version is included in Visual Studio 2012 and 2013. So I'll create a new project, tutorial 7, and if I go to add NuGet packages, and I haven't quite learned how to use this user interface, but if I enter Deedle, then it shows me 2 different packages. Both of them are currently pre-release, so you'll have to mark this, switch this drop-down to include pre-release. The first one, that's just the data manipulation library. This one also includes the R type provider plugin, which lets you interpret with R. And the second one also installs things like the R provider itself, so there's more dependencies. Now if I just install this, or maybe let me install this one as well, that should, if it works, then it will download, well, that one is already downloaded, and it should download the R-type provider, which is sort of independent, but this one relies on that as well. So that's happening.
It takes longer to resolve the dependency when it's already installed.
So R.NET does all the in-memory stuff then?
Yes, R.NET is sort of C# style library for calling R, which the R provider is using. And this does some magic along the way. So hopefully, if this all works, then I should be able to go to packages, and go to the R provider and reference a few things there. I'll need to enable that. So one of the things we want to do as part of the FS Lab idea is that we'll want to give you just a single package where you don't have to reference everything separately. Because now I need to do this again, and I'll need to go to Deedle. This is the file that is included with the package, and that I can just load. I'll just need to make one fix here. So if I do load on this, then that does, in the end it actually worked, hopefully. So now we can open Deedle, which is the namespace where all the frame and series functionality is. And we can also open the R provider. And actually, this is using the R provider. The R provider looks at your R installation, so I can do things like open R package. And the reason why I'm doing this is that I want to show you that we can get data from R. So this is the sample data set, and we can get this as a value. And if everything, probably need to open some more things, even more things. Well, if this doesn't work, it's unprepared demo, then don't worry. Yeah, in principle, I should be able to take the empty cars data set from R and convert it to Deedle. The problem is, when I created my project, I created it without a folder for solution, so something broke along the way. But I'll go back to the actual sample that I wanted to go to. So this is already set up, and we'll send a link to the user group. And it references a whole bunch of various F-sharp data libraries. So all the things that would form the FS Lab. And we'll start by reading some data. So frame is the module that you will use to work with data frames in Deedle. And this will load data from a CSV file. So I'll dock F-sharp interactive here. And you can see that it's printing the information from the file in some nice way in F-sharp interactive. So here's all the Titanic passengers. There's various columns like survived, and this is actually showing that it's heterogeneous because like name is a string, survived is a boolean, and so on. So if we wanted to check how many people are there who survived the Titanic disaster, then we can say Titanic, and we want to filter the rows and get only those where the person survived. So there's filter rows. You can see all the different functions in the module. So we'll filter rows, and this will call a function I specify with the row key, which is in this case just int offset, and an object series representing the row. Object series is just a series, just like ordinary series, which has the values of type object. Because it's heterogeneous, we have to use .NET objects. And here I can get a column named name survived, and I can get it as a Boolean. So this gives me back a data frame where I have only the people who survived, and I can do things like frame count rows. So there's 342 survivals. If I add not, then we'll get 500. So this is sort of showing the basic data frame processing, and we did some calculation with it. And so let's look at some more interesting data analysis research style operations. So what is the comment telling me? That I want to group the Titanic data set. This is one really useful operation. So if we have the data set, then there's 3 different passenger classes, 1, 2, 3. There's different embarkation points, and we might think that people traveling the first class are probably the ones who get into the safety boats. So let's see if more people in the first class survive. Now I'm going to use grouping operation, and I want to group this by P class, which is the name of the column, and I'll also want to group this by string, and the column name is, I believe, embark. Let me see, yes. And this really just restructures the data frame. Let me do one more operation to order all the rows. And what I'm getting here is a data frame where, if you look at the index, now the row index is actually a tuple with a string int and int, and you can see here that the string, the first part is the embarkation point, the second is the number, that's the class number, and the third is just the index, the unique index of the row. So I've restructured the frame, and I think I want to switch it like this actually. And then you can do other operations on the row keys. So I'll just use a simple function that turns the tuple of tuple into just a single tuple. So now I have a data frame which has some sort of nicely structured data, and then I can do the interesting things like take the average age for each group or count the number of survivals for each group. So this is my data frame, and the first thing I want to do, so let's just take average of every column, which might not make sense for some columns, but we can start with that. So I'm using a few helper functions from pair, which is like our helper module for working with tuples. But this is basically just saying, take this and calculate mean based on some level in the hierarchy. And I want to get the level which contains the first and the second element. So if I do this, I'll make this a bit bigger, then we are getting averaged columns for the different combinations of passenger class and embarkation points. So for example, some of the data is now missing because you can't take averages of strings, so that is dropped. But for example, you can see there's different average ages. That might be a useful thing to look at. Now, what do we want to do next? So let's actually just take, and I guess one interesting thing here is that we have a frame which has some really complicated key structure, but we can still work with it as with any other ordinary frame. The keys are one aspect, but all the functions work regardless of what keys you have. So we can get a series, and there's a few operations that are better done using the .NET style dot notation or C# style dot notation, especially when you need to pass it some generic argument. So here we are saying, give us just the survived series with values of type Boolean, and this gives me back a series with the same row index. So I still have the complex information about the rows. And here I'm using that to track some information about the passengers. But if you're doing that in finance, then this would be your like dates or times. So the fact that the row keys are always tracked, that's probably one of the most important things. So this is my series. And what we want to do next is that we want to count how many people survived or died in each group. So we'll take this, and this time I'm working with just a single series. So I'll use series dot, and what do I need? I need to use, so we use the keyword level whenever you're working with one level of the hierarchical multi-level index. And apply level is a function that when we specify which level we are working with, it lets us aggregate all the things in that level. So if I say, again, we just want to use both of the keys, and this gives me a single series with the survived flags for individual group. And from series, we can just get a list of values, list of booleans, count that by identity, which gives me, well, let me actually run this. So if I do just this part, then for every group, we'll get like a tiny series which contains mapping from true and false to the number of people with that survival flag. And if I have, so the overall thing I'm getting here is a series of series, and I can turn that into a data frame by doing frame of rows. So now I have a data frame which is like a summary of how many people survived and died in the different groups. And the result, the type of this is that int string is the row key and Boolean is the column key. So we actually have a data frame with fairly interesting keys. But we can replace the con keys true and false with strings, which gives me something like this. And now I have fairly standard data frame where the column keys are strings. And if you have a data frame where the column keys are strings, then you can also use the /# question mark operator. So we can get a single series from the data frame representing who survived. Or if I do this again to get just the length, the total number of people in each group. So this would be just group that using series dot count values. So I have a data frame with how many people survived, how many people didn't. And I have a new series with the total number of people in each group. And they share the same type of row keys, which means that I can add this to the data frame. And now I'm mutating the data frame. So this doesn't return anything. That just mutates the data frame. But now I get the data frame where I have the total number of people and the different groups. So if I want to do one last thing, take the number of survived and divide that by total and multiply that by 100, then I'll get percentage of how many people survived in each group. Now for the first one, there was just a single person, so that's not telling us very much. But you can see that being in the third class wasn't a good position. First and second is better. So you might want to consider that when booking your next trip. The nice thing here is that I can work with these series, like I can apply numerical operations on them. So this is doing pointwise division on two different series, and it aligns them properly. So if like one had a missing data for the first class, it would actually understand that, and it would know that it needs to skip that and only divide the values where we have both of the data sets. Okay, any questions so far?
Yeah, I was wondering, can you clone a data frame?
Yes, you can clone a data frame. There's a clone operation.
Will that share structure, or is it?
It will share the data of the series data, which is immutable. And it will actually share the indices. There's like some internal structure representing the index, and that's immutable as well. But when you add things to a data frame, it creates a new version of the index and keeps that.
So it's immutable under the hood.
It's immutable under the hood. It's just, well, it uses immutable data structures to represent everything, but it stores them in a mutable field, and it mutates that field. So when you add things to a data frame, it will create a new index and then override the old one. But cloning is cheap operation. Any other questions so far? So that was my first sample, and all of them will be on the GitHub page. So this was showing how to use Deedle. I haven't really done any F-sharp charting, which I wanted to do, but haven't done. I'll do that in the next step. But we've used the Deedle for doing some data exploration, and we've done a fair amount of the hierarchical multi-level indexing, which is one interesting feature. But there's other aspects that we'll demonstrate in the next samples. Other questions? Yeah.
No, I was just wondering, why didn't you take it to the next level and try to backward engineer, like saying, taking age and sex and class each, pick a class, and then try to determine the survivability. So,
yeah. No, that would definitely be an interesting thing to do next.
yeah, because some of the ages are missing, if I remember Titanic data. So then you have to take their names, like if it's a miss, and make a judgment on, what range of age they would be in this kind of.
Yeah.
Because
We look forward to you posting that on your blog.
Indeed. And for those who weren't excited enough about Titanic, I have other exercises. So I'll sketch how to work with stock prices, and then you can continue and write blog posts on stock prices. So let me switch to my second sample. And this is again using the same setup. This time I actually want to use Deedle together with the CSV type provider, which we have in F-sharp data. I demonstrated in the previous sample that we can just load CSV file. So you can just load CSV files. The benefit of using the CSV type provider is that it gives you sort of easier way to do some type safe pre-processing if you want to do that. So if I iterate over all the rows, then I need to do something else. Rows.stocks.data. Then here I can just print r dot, and this is using a type provider mechanism to be type safe. So I can see that here's my column names from the CSV file. So if I want to print the opening price, then that gives me the opening price. And I actually have a sample, which I can just copy and paste here. So this is using the stocks type. It loads the stock data from a CSV file, which I have locally, because I don't trust the internet. And I'll get the date and the opening price, reverse that, and turn that into a series. So I can get time series with all Microsoft stock prices since 1986. There's like a printer registered for F-sharp Interactive, which prints you first few things, last few things, and dot dot in the middle. So we can actually see it in a fairly reasonable way. And this is a time series with key being the date time and value being float. So we can, for example, take the mean and Microsoft on average, that's $60. Another thing you can do with these series, so there's a series and it may be ordered. And if you have an ordered series, then you can do more with it. And one thing you can do with ordered series is that you can use slicing. So if I say something like this, first of all, this would just give me a value for the specified key, which fails in this case because there's no value for January 1st. I suppose there's like a value for January 4th. There's other ways to get the value, so you can handle that without exceptions, or you can say, give me the previous value that was available. But what I wanted to do here is that I wanted to show you that I can use this dot slicing to get a series which is only with the 2013 data. And now it doesn't actually matter that the exact date isn't there. So this is MSFT in 2013, and I can take the mean of that, which happens to be 31. So to do some charting, I'll actually use the F-sharp charting library, which is really basic. And we have an extension that lets me pass a series to chart.line. So here's a line chart with the stock prices over 2013, and you can see that it picked up the keys correctly as well. So that's a fairly easy way to create charts. And what did I wanted to do next? Yes. So another common operation, there's like loads of operations on series dot. So you can go through the list or browse our nice documentation. But I want to do a floating window, and again we have multiple different ways of doing that. You can say I want a floating window just over 5 values, or I want a floating window where the length of the window should be 1 week or something like that, which is maybe that's probably more useful than saying I want just 5 values, because that might not correspond to a week if there's like non-business days. But I'll just use 5, or to make it more exciting, 15 days. If I do this, then I get a series of series, which I could then process using series.mat. We also have series.window into, which just calls this aggregation function on every single one. And this gives me back the averages. Now you can see here that this handles the keys in a sort of reasonable way. So the first value, that's actually the key at the end of the window. Because in finance, I'm always told by people at BlueMountain that I can't look at the future values. And they probably have a point. So this is taking the floating window over the past 15 values that are available and assigning that to the last key. So that's one nice thing about Deedle, is that it's being reviewed by people and used by people who actually know this stuff. So it's behaving reasonably. So I have my floating windows, and I can combine the two charts. So this is showing a floating window over the last 15 days or something, and you can see that the yellow line actually starts here, and then it's averaged. So, yes?
15-day moving average, you're saying?
Yes, 15 values.
15-day moving average.
Yeah.
So that's smoothing the curve.
Yes, that's exactly what's happening. Yes?
I mean, you're using the R package to do the charting. Can you do like change the y-axis to have a scale like it's?
I'm using the F-sharp chart library, F-sharp charting library.
Oh,
which,
I'm sorry. Okay.
I can definitely do with y-axis, and then this will take something like min 20, I think. Yeah. Or this has a clever hidden feature. You can hit Control G, and it displays a property grid where you can make it actually look nicely.
Okay.
If you want to then save it, which you can do using right button click and save. But I'm using this because it's really easy to use, and it works nice in F-sharp interactive. But in the later samples, I'll show you how to use the ggplot tool library from R as well, and that lets you tweak it in enormous number of ways. So that was working with just a single stock price. But what if we want to do something like that over multiple different stocks? So let me cheat again and find my cheating window. And instead of getting just Microsoft stock prices, that was the wrong one, I'll build a data frame which has data for multiple different companies. So here we'll take Yahoo, Google, Microsoft, and Facebook. We'll say, give me the time series, and this fancy arrow operator, that's what we basically use to say assign values to some key. Internally, it really just creates a tuple. So we have tuples with the stock and the time series, and then we say frame, which turns that into a data frame, and we also order the rows. So now we have a data frame, and there's plenty of missing values because the keys are the outer join or the union. So we have some missing values, some data is available. I could do various things to handle that. For now, I think I'll just say drop sparse rows, which gives me a new data frame where I only have the values, only have the rows where all values are available. So let's call that tech2. And one thing we might want to calculate is the daily returns on the stock. So that's basically, we want to say for every day, figure out how much has the value changed since the previous day, and then divide that by the current price to get like ratio, and get some sort of percentage of how much we gain from the previous day. So, and I want to do this for all the stocks in the data frame. So this is my data frame again, and now I need to take this and subtract from that the previous values. So we have a useful function called shift, which basically keeps the keys and shifts all the values by 1. So for every day, we'll now have the previous value, the previous price of the stock. So if I subtract this from the tech2, then I'll have the differences, from the previous day. And if I divide that by the today's price, then I should get daily returns. And I can just multiply that by 100 to get that in percentage. So here's in percentage the change of the price, and I just calculated that for all the companies for all the days in the data frame. Now, if I want I guess what I can do now is that I can just take the averages for all the columns. So let me type this into chart.column, and now you can see which company has the largest average daily returns since
Since last year.
It's since Facebook went to the stock exchange. Yeah. So yeah, I don't know what happened with Yahoo. Yes.
So I was just looking at, if you were ranking the daily returns, the order, if you could remove the chart, I think you have order by up or order rows up there. Doesn't have a parameter, so is it defaulting to order by date?
It's just using the default ordering on dates,
So
because these time series are the time series have the date as the key, and date defines some ordering. So that's just using the default ordering on date, which is that.
So you can just supply the column name for the return and rank them by returns or something?
Oh, if I wanted to, well, so if I have like this, then, so ordering only, I can only order, at the moment, we can only order the data frames based on their indices, because that's how, I guess, that's the most useful operation, that's the most useful sorting. If I wanted to do something else, like order them based on the average return for the day, then I could just get the values of the time series or the observations and do that. I guess we should probably add ordering on on different things. We just don't have the function for it there yet. But I think we would accept that as a pull request. It's just a missing feature that would be useful. Yep.
Can you do anything other than just drop the sparse rows? Like use the prior day price, for example?
So if I don't do this, if I just comment this out, then there's some bug somewhere which I'll have to fix. So in principle, you should be able to just work with the missing data, and it would propagate them. I'm not. Oh, this is actually fixed in the build on my machine, but because this is getting the official NuGet package, then the shift function is broken. But I'll release a new version later today.
But you can also like fill down the
Yeah.
fill
Yeah.
down the prior values or replace
I
them.
think, exactly.
Yeah, so if I wanted to do that, then I could say frame fill missing, and there's a version that takes a constant like 0, or I can specify a function, or I can specify a direction. So if I do this, then I'll get, and that's what I'm probably not allowed to do, because that's filling the prices for like Google in 1986 with the first price. But that's a wrong thing to do. But you can fill the missing data with just propagating the values that you have available. Okay, so the last example I want to do using the stock prices is to do the same thing, but using a hierarchical data frame. So let me just get one more code snippet here. And this is building a data frame where I have multiple different companies, and I have different different sectors for the companies. So if I do this and build my data frame, then I have again a data frame, but this time I have two-level column index, string and string, where the first level is the sector, like consumer goods and financial technology, and then there's a bunch of companies under that. Interestingly, Yahoo tells me that Apple is consumer goods. So that's my data set, and I can just use exactly the same operation that I used before. So let me just copy and paste that. So I'll again just drop the missing data for the purpose of the demo, and press all, and I'll run exactly the same calculation over this more fancy, more complicated data frame, and now I have all the different returns for all the different companies. And if I apply frame.mean on this, then it does the aggregation. Well, previously I had this structure as my column keys. Now I have a series which has this two-level index with the different sectors and the different companies in that sector and their returns. So if I wanted to plot this, then I could say net row keys SND just to build a flat data frame with only the company names. I didn't run something. I didn't run this, or this was broken. Oh, right. So if I comment out this, then it tells me what's wrong. The problem is frame.mean. That gives me a series with aggregates. So this needs to work on series. And series just has map keys. And I can pipe this into column, chart, column. And that gives me returns for all the different companies. It's not actually showing the labels in a very useful way. I could do something over here to tweak it, but I don't want to waste too much time clicking through the user interface. So there's a question.
Yeah, can you actually like aggregate across rows? So for a date, you have to get the mean of all the companies. Can you
Yeah.
get-
I'll keep that in a buffer.
Okay.
Finish this sample and then show that. So the thing that I wanted to do before is to actually aggregate this by sector. So we can say once we have this series, then we can say series, and that's again applying something to a level. So if I say mean level by first, then I'll get the averages by sector, and I can show the column chart by sector. So consumer goods overall isn't doing that well. And the other question was, how do I get daily averages, daily returns across multiple different stocks? So to do that, I can just use frame.transpose, and that rotates the frame, and that's using the fact that we actually have this symmetry between columns and rows, and then I can just apply mean to this and plot that. Well, that's not very sharp. Maybe I can do area. Will that be any nicer? That's even worse. But this is showing me the daily averages across all the companies I have. Okay, any questions on this sample so far? Yes?
So you have a function, a frame mean, but if you wanted to use autocorrelation or something like that you don't have a function for, you can just call it to R or MATLAB or something.
Yes, we could. So there's a bunch of options. We have a few more sort of simple statistics functions, which are just calling math.net. So we rely on math.net, and that implements many of the other functions you might want to use. If you have the function implementation in F#, then you can use something like apply level or something where you can just provide like IEnumerable of values to something function. If you want to do some advanced statistics, something that's not in standard like F# libraries, or something that's available elsewhere, then either there is some .NET library, like commercial .NET library that has it, and then you can get the data as like list of observations and pass that to some other library. Or you can use the R-type provider as well. So if I have if I take this and do map column keys SND, just to get like fairly simple data frame which has just the company names, then do I have the R provider here? Let's see. R provider. I can open R provider base, and I should be able to say R dot as data frame. And what happens happened now is that it actually passed the data frame and built our data frame in R, which is running in process. So if I knew some function that works on our data frames, which I don't, then I could just find it here. I'll scroll this up. Maybe the r.mean function actually works on data frames. So if I do that, well, there were missing values, so I get none. But if I drop all the sparse rows and do this again, so what I'm doing right now is that I'm calculating the mean inside R, and if I had some fancy R package that does something more, then I could call it in exactly the same way. So this is the result here. You can see this is R.net symbolic expression, which is some like representation of value inside R, and the printout you can see there. That's what R prints. And
you don't have to explicitly do as data frame there either. I don't think.
That's right. Yeah. Yeah. So I use as data frame just to sort of explicitly force it to take that, to convert that to a data frame. But all the R functions that work on data frames, when you call them from F# with Deedle data frame, then it automatically converts the Deedle data frame to the R data frame. And when I evaluate this, I can actually say, dot value, and that did some. Oh, this is I suppose this is a series. So if I say get value series, I'm not entirely sure if this is going to work.
I think it's just a list.
It's probably just a list, yeah. Well, I might be able to convert it, but maybe not. No, not. Yeah, this isn't convertible to a series. I could get the values just by saying value or get value float array, and I need to call it, and this gives me data back as float array. If you have something that's R data frame or R series, like what I tried to do in the previous sample, what I tried to do at the beginning, if I open R provider datasets and take r.empty cars, then that's a data frame which still lives in R, but when I say get value frame with rows, which is int, and columns of type string, and I would have to use my local version of the library. If I say just dot value, then that actually gives me a data frame, which I can then cast to Deedle frame in string, or I think I get the row and key indices wrong.
I think it's string string, right?
Oh, right. That's it. So maybe I would actually be able to do this. Yeah. So there's a sort of plugin into the R provider that when it understands this type that you're trying to get, and when the data source is a valid data frame, then it does the conversion behind the scenes, and it gives you the data back as a Deedle data frame. So the result here, if I look at the type, that's just frame, string, string. Yeah?
you don't need to show it. I'm just curious. Like, so since you're built on top of math.net, is there a fast way to turn a data frame into a matrix?
No, we don't have that yet. I think that's probably useful feature. Definitely something we could add.
That could be your fault.
Sure.
Yeah.
Yeah.
Okay, so in this sample, I use Deedle to do some basic statistics, and I also use the fact that there's like the symmetry between rows and columns. I can transpose it, do some aggregation over rows or over columns, and I also use the F-sharp data type providers just as a way to explore some CSV files. But that's also something I want to use in the next sample, for which I believe I have 15 minutes, where I want to show you something that connects multiple different data sources and does some interesting analysis over that. So I'll open my third sample, and given that I have 15 minutes, I'll probably do a bit more of the copy and paste rather than just typing everything from scratch. But I'll type the interesting parts. So what we want to do first is that we just load some CSV file with US depth, and the CSV file has year column. So we want to index the rows of the data frame by the year, and this also has some ugly named columns, so we'll rename that to just year, GDP, population depth, and question mark because I don't know what the last row means, the last column means. So now we have a data frame with GDP and depth, and I got this somewhere from the internet, so obviously it's right. And what I can do next is that I had to use this CSV file instead of my lovely WorldBank type provider, because the WorldBank doesn't know the depth data over the last 100 years. They only have it over like 15 years. But I can at least do something like get the WorldBank data for the GDP, which is easy. So countries, United States, indicators, GDP, and I think I want this in GDP. What do I want?
You want
I
depth?
want this.
You want depth?
No, I actually want
Oh, you
GDP
want
because the depth is different, but I want this in GDP in current US dollars. That's what I want. So this gives me indicator information, which I can convert to a series easily. So now I have the data as a Deedle series, and I can align this with the data I have from the CSV file and see if that matches. So if I take the depth data frame and say GDP World Bank, and I'll just assign this value here, then I have a data frame which has the data from the World Bank and the data from the CSV file, and you can see that there's some missing data because the World Bank doesn't have that for all the different days, all the different years. So if I just quickly combine a chart which shows depth data GDP and depth data GDP for the World Bank, then I see that they're completely different because I forgot to divide the GDP from World Bank, that's in single dollars, but this is in billions. So they're dramatically different. And I can just divide this by 1, 9, and then I can see that the CSV file data, which is the yellow part, overlaps with the sorry, the CSV has all the data, so that's the blue part, and yellow is the World Bank. So at least the GDP matches. So hopefully the CSV file is right with the other numbers as well. So this was showing that if you have series and frames which have the right index, like year, then you can just align them, add them as a new series, and it aligns them automatically. The next thing I want to do to make this talk more exciting is that I want to take that information and align it with some data I can get about the US presidents. So to do that, I'll use the Freebase type provider. So we'll take Freebase data, get data context, and when we have that, we can say, if I remember where this was, that's society, government maybe, US presidents. So this gives me a list of US presidents. I can take the first president, head, and that's Abraham Lincoln. So here's his name. And on president, we have access to all the other interesting properties, like government positions held. So his first government position held, if I get that into a variable, then I can get something like from and to. So these are the dates. And the basic title of the position. So you can see that Abraham Lincoln was president from 61 to 69. And that's getting the data live from the Google-owned Freebase web database. So you can explore this, and the Freebase type provider, that's just a beautiful way to waste so much time. So we can get the data, and I think I also need to do one change here in the previous part, because I just want to get the depth. So this is just giving me a frame where I only have the depth. I'll need that later on. And now I want to get, I can use the query syntax to query the Freebase and get all the presidents who have higher index than 23. And that happens to be presidents over the last 100 years. So that's just a query. And then the interesting thing, this is a little bit more typing. So this is iterating over all the presidents. And that query, that first part, that was actually running in the Freebase thing. So we can get all the presidents, get their government positions, which were president, get information about when they started, when they ended, and which party they belonged to, and then return that as a tuple. So this gives me all the information as a plain F# list, And if I have a plain F-sharp list with tuples or something, then I can use the off-records function, which uses reflection and looks at the underlying types. So this works nicely with records. Here we'll just get like item 1, item 2. So we'll have to rename the columns of the frame to get a nice data frame with information about presidents. And when we have that, we can index that data frame by the end year. So here we'll get for every year when someone finished being the president, we'll have that name and the other information. And now comes the interesting part, because we have this data frame which has the presidents, and we have the depth data. So depth data, that has for every single year the number, and we can use a joining operation that says do a left join and align depth to the by end information about presidents. So we'll get a new data frame where we have all the information about presidents, but also the depth at the end of their term. And the depth is in percentage of GDP. So
I have a question.
That you need.
yes.
If you were to just assign in that series, what would
Oh, that would work as well. Yeah, I could just do something like that equals, or yeah, I could mutate this one and say that depth. This is a data frame. So depth is a data frame. If I take just a single series, then I get something that's assigned, that I can assign to by end, and that does the alignment automatically. So that's the same that will work too. Yeah. Yes.
Well, one thing, you have to make those GDP numbers real numbers, in the sense that since, like, you go back to 61, $1 today has lost 92 cents of its value. So you have to, I mean, otherwise you don't get a fair
That's why the
comparison.
net was in current dollars.
It's percentage of the
It was in
GDP.
current dollars, nothing.
Okay, I know, that's what I'm saying, current dollars, you have to,
But
because you're,
the end, the number that I have here, that's a percentage of the GDP in that year. So that's, for every year, the number is that in the percentage of the GDP in that year. So that's just a ratio. That's like unitless value.
right, but,
So that should be a fairly meaningful.
well, but in years that they had high inflation, it's going to, you have to adjust for that. I mean,
Oh.
because.
Yeah,
it's just-
that's another interesting block.
I mean, otherwise you're not.
Well, this is just.
I'm just writing the library and writing sketches.
I know it's demo, I know, but it's just, to me, I look at it and think, it's like.
I think I have
useless.
roughly 1 minute to finish. So instead of trying to make any political argument, I'll just show you some nice charts.
That's more like it.
Oh no, this is my party. I'll skip that.
Let's do it.
I'll skip that.
Go ahead.
You can run that in the pub.
If you think you had an argument before, let's see the charts and we'll do it.
So this is calling the ggplot library to do the visualization. And this is just the default call, where if we call qplot function and give it the keys and the values and say, give me a line, then it does this. But if I copy a few more things, so this will generate some nice labels with the year and the president, and then I can call I forgot to run one more thing. So I need to get differences, which is this, depth minus, and that series shift 1. No, it's not working. Well, I have a backup plan, which is another copy of the solution where all the samples are working, which is the one we'll put on the website. So I don't want to waste the last -1 minute of my time. And I'll just go here, here, run all of this. Oh. Was that this Visual Studio or the other?
Get too high, virtual overflow.
Maybe I do need to get a new computer. I'll blame the alt RAM. So where's my Visual Studio again? If it fails again, then I'll just keep that to the pub. Samples, or you'll have to run it from the presentation samples. So let me try this one last time, and if it fails, then there's no beautiful charts today. So let me go to the presidents. And I want to run everything here. Use the archive provider to give you a nice chart. So this is showing the differences for every president. We have color, which is based on their political party, and then this is showing the difference from the depth in the percent of GDP at the end of their term compared to the beginning. So you can see when it like goes up and goes down depending on different presidents. And I will not show that long enough to make any arguments. And that's you can play with the samples more. We'll put them online, and that was the last sample where I just wanted to show that Deedle actually works nicely with things like R, where you can do more complicated analysis and nicer visualization and stuff like that. So we have last 2 slides, I think. One is Deedle needs you. So the library is available on GitHub, so you can play with it. It's available on NuGet, so you should be able to use it easily. Ask questions, report bugs, or write nice blog posts based on the ideas you get during the talk.
I just want to mention one thing which I didn't emphasize at the beginning. It is just as usable from C#. So if you're somebody who wants to use F# but you don't get to do so in your day job, you can still use it and improve the library, and it's pretty much as usable. We at BlueMountain use it from C# really extensively.
There's using from C# with some documentation on how to use it from C#. Here's your link query. And I guess maybe, Howard, if you want to say a few words about the grand vision at the end.
Well, it's really Tomas's vision.
Well, I booked the domain, but that's all.
Well, I guess the vision in FS Lab is things we need to do in the future compared to what we have now. Visualization. The F# chart library is is fine for basic visualization, but we have, I'll stand up to you.
Yeah, you can try S3 yet?
But we want to use a library called, so you'll probably talk about D3.
D3,
There's a higher level library called Vega, which is more suitable for visualization. So we'd like to, actually Matthias is working on making Vega easily usable for F-sharps. That's one thing we'd like to do to improve the visualization capabilities. Right now our support for non-Windows platforms is kind of patchy. So some things like Deedle works fine on Linux and OS X. The R provider is just getting there, but it's kind of not great. One thing that we really like is to have a much richer interactive experience, so that you can have your interactive console and have inline visualizations of grids of data and be able to pull them out and dock them into your IDE and produce reports and things like that. Exactly how we're going to achieve that, we're not yet sure, but that's something we like. Excel integration, we have some of this actually BlueMountain kind of in-house. It's not yet open source, but we'd like to kind of open source something where you can kind of take what you have in a Deedle data frame, for example, and then spurt that out to Excel, or keep an Excel view on the data frame in sync with how you're manipulating it, so you can visualize it, slice and dice it. I guess more integration with more data sources, which is kind of something data science working group and the finance working group be able to access other kinds of financial and non-financial data sources and integrate better with them. And a bazillion other things, but those are the things I thought of. And that's it, right?
Yeah.